Hello everyone, my name is Prasanna Kumar and today I am going to present my TED Talk on trustworthy AI framework, which is an important topic in an AI foundations. Artificial intelligence is being used in many real-world applications such as healthcare, transportation, finance, and aerospace. But as AI systems become more powerful, it becomes very important in that these systems are safe, reliable, fair, and transparent. In this presentation, I will explain the concept of trustworthy AI, its key pillars, techniques used to ensure trust and challenges in building responsible AI systems. Introduction to trustworthy AI. Trustworthy AI refers to artificial intelligence systems that people can trust and rely on. For AI to be trustworthy, it must be reliable, fair, transparent, and accountable. This means AI should make decisions that are ethical and understandable. It should not harm people or create discrimination. The European Commission proposed several principles for trustworthy AI, such as human control, safety, transparency, privacy, and accountability. Trustworthy AI is especially important in high risk industries like healthcare, aviation, and autonomous vehicles. In such fields, even a small error in AI decisions can lead to serious consequences. Therefore, building trustworthy AI ensures that AI systems work according to societal values and safety standards. Core pillars of trustworthy AI. There are three main pillars that define trustworthy AI. The first pillar is lawful AI. This means AI systems must follow all legal rules and regulations related to data usage and privacy. The second pillar is ethical AI. Ethical AI ensures that AI systems respect human values and avoid harm or discrimination. The third pillar is robust AI. Robust AI systems are technically reliable, accurate, and secure even when facing unexpected situations. These three pillars work together. For example, fairness requires both ethical principles and strong technical design. Fairness in AI. Fairness in AI means that AI systems should not discriminate against people based on sensitive attributes like gender, race, or age. If an AI system is biased, it may produce unfair decisions. For example, an AI hiring system might prefer certain candidates due to biased training data. Researchers use several fairness metrics to measure whether an AI model is fair. Some examples include statistical parity, equalized odds, and predictive parity. However, fairness is complex because one fairness metric may conflict with another. Therefore, developers must carefully choose fairness methods based on the application. Bias detection and mitigation. Bias in AI can occur in two main ways. First is data bias, which happens when the training data does not represent all groups equally. Second is algorithmic bias, which happens when the learning algorithm unintentionally favors certain patterns. To reduce bias, researchers use several techniques. Pre-processing methods modify the training data before building the model. In processing methods change the In-processing methods change the learning algorithm to reduce bias. Post-processing methods adjust the model outputs after training. Tools like AI Fairness 360 help developers detect and reduce bias in AI systems. Explainability in AI. Explainability is an important part of trustworthy AI. Many modern AI models, especially deep learning systems, behave like black boxes. This means it is difficult to understand how they make decisions. Explainable AI helps users understand why a model made a certain prediction. There are two main approaches. First is interpretable models, such as decision trees and linear models, which are naturally easy to understand. Second is post hoc explanation methods like LIME and SHAP, which explain complex models after they make predictions. Explainability increases user trust, transparency, and accountability in AI systems. Robustness and adversarial attacks. AI systems must also be robust and secure. Sometimes attackers create adversarial examples, which are slightly modified inputs that trick AI systems into making wrong predictions. For example, a small change in an image could cause an AI system to misclassify an object. Researchers develop defense techniques such as adversarial training, which trains the model using both normal and adversarial data. Other methods include gradient based defenses and randomized smoothing, while which improve model stability. Robustness ensures that AI systems continue to perform well even under unexpected or malicious conditions. Privacy preserving AI. Another important aspect of trustworthy AI is protecting user privacy. AI systems often use large amounts of personal data for training. If this data is not protected, it may expose sensitive information. One popular technique is differential privacy. Differential privacy adds controlled noise to the data or training process so that individual records cannot be identified. Another method is DPSGD, which modifies the training algorithm to protect privacy. These techniques allow AI systems to learn useful patterns without revealing personal data. Secure AI. Security is also critical in AI systems. Some attacks try to steal machine learning models by repeatedly querying them. Other attacks, called membership inference attacks, try to find out whether a person's data was used during training. To prevent these risks, researchers use techniques like federated learning. In federated learning, data stays on local devices and only model updates are shared. Other techniques include encryption and homographic encryption and secure multi-party computation, which allow computation on encrypted data. These approaches protect both data privacy and model security. Accountability in AI. Accountability ensures that organizations take responsibility for AI system decisions. Developers must document how models are trained and how they behave. Tools like model cards and data sheets provide detailed information about modern performance training data and limitations. Audit trails also record model inputs and outputs for future analysis. Independent audits help verify that AI systems follow standards and regulations. This transparency helps build public trust in AI technologies. Human in the loop AI. Human in the loop AI combines human intelligence with machine learning. Instead of fully automated decisions, humans are involved in important stages of the AI process. For example, experts may review AI predictions before making final decisions. Techniques like active learning allow humans to label the most important data samples. Human AI collaboration improves reliability and reduces the risk of incorrect automated decisions. This approach is especially important in high risk applications. AI governance. Governance refers to the rules and policies that guide the development and use of AI. AI governance. Governance refers to the rules and policies that guide the development and use of AI. Governments and organizations create frameworks to regulate AI systems. For example, the EU AI Act classifies AI systems based on their risk levels. The NIST AI Risk Management Framework provides guidelines for managing AI risks. International standards such as ISO also help define technical requirements. These frameworks ensure that AI development remains safe, ethical, and legally compliant. AI lifecycle management. Trustworthy AI must be maintained throughout the entire AI's lifecycle. This includes design, development, deployment, monitoring, and retirement. During development, engineers must include requirements for fairness, privacy, and safety. After deployment, continuous monitoring is needed to detect performance issues of biases. Version control and rollback systems help manage model updates. Proper lifecycle management ensures that AI systems remain reliable over time. Case study. Case study. One practical example of trustworthy AI is in autonomous aircraft systems. AI is used for navigation, obstacle detection, and decision making during flight. To ensure safety, these systems use redundancy testing and verification. Explainability tools help pilots understand AI decisions during emergencies. Privacy technologies protect passenger and operational data. Regularity organizations require strict testing before such systems are deployed. Evaluation metrics. To evaluate trustworthy AI, researchers use several metrics. These metrics measure different aspects such as fairness, robustness, explainability, and privacy. For example, the fairness metrics compare prediction outcomes across different groups. Robustness metrics measure model performance under noise or adversarial attacks. Explainability is evaluated through user studies and feature importance analysis. Privacy protection is measured using differential privacy parameters. Together, these metrics help assess whether an AI system is truly trustworthy. Challenges and research problems. Despite many advantages, building trustworthy AI still faces several challenges. One major challenge is balancing fairness, accuracy, and privacy because improving one may reduce the others. Another challenge is verifying the large deep learning models. Different countries also have different AI regulations, making global deployment difficult. New AI systems like large language models introduce additional risks related to transparency and control. Researchers continue to explore solutions to address these challenges. Future directions and conclusion. In the future, trustworthy AI frameworks will combine advanced technologies like causal reasoning, formal verification, and hybrid AI models. Automation may also help perform AI audits and compliance checks. Explainable AI will become more interactive and user friendly. Global standards will continue to evolve to ensure safe AI adoption. In conclusion, trustworthy AI is essential for responsible technology development. By focusing on fairness, transparency, privacy, and robustness, we can build AI systems that truly benefit society. Thank you for listening to make my presentation. I hope this talk provided useful insights into trustworthy AI frameworks. Thank you.